Hello, konnichiwa, ni hao and guten tag. Welcome to Burlington House here in London. And we're here with a special panel on progressive plastics to mark the end of 3 days of scientists from countries including Germany and China and Japan and the UK all being here together, trying to share ideas, share their knowledge about the best way to tackle the problem of plastic pollution. Plastic pollution is something that hasn't actually really been a phrase for very long. For years, decades in fact, people lived quite happily with this versatile, useful, waterproof substance. But things have changed in the last few years. We've all become a lot more aware of the problems that plastic can cause when it gets out into the environment. No thanks to Sir David Attenborough, who's really drawn attention to the problem through his show Blue Planet 2. The number of Google searches, for instance, for phrases like plastic pollution and beat plastic pollution weren't really used before, but now they're being described as breakout phrases. And actually, the increase in the number of times they're being used is too high to quantify. So we've seen the problems that plastic can cause, and more people therefore want solutions. Is chemistry going to provide us with the answers? Before I introduce you to the people on my right, I just want to say that if at any point you want to join in with this discussion, we'd love to hear what you think. Elizabeth Ratcliffe from the Royal Society of Chemistry is on my left, and she'll be processing all your comments that you make in the live chat and on the Facebook page. And also feel free to tweet us, Royal Society Roy Soc Chem, and the hashtags are progressive plastics and RSC sustainability. So, in no particular order, we'll go from the far right. We're joined by Professor Xianhong Wang from Changchun Institute of Applied Chemistry, then Professor Charlotte Williams from the University of Oxford, Professor Andreas Greiner from the University of Bayreuth, and Professor Toshiaki Yoshioka from Tohoku University. I hope I said all those right. Thank you all very much for joining us today. Can I just say it's really great news that after 3 days of being locked in a room trying to solve one of the biggest problems in the environment, you're all still smiling and chatting to each other. That's really good to hear. First off, just a quick question is, how do we look at the impact that plastic has, both negative and positive? Xianhong, can we start with you? What do we look at?
Yeah, as a polymer scientist, I really believe plastic should be positive, and it has positive impact in human beings and in the world. Yeah.
And how do you quantify the positive, and how do you line it up with the negative that can come from them?
Yes, the point is you know, countries in the world, we use almost 300 million tons of plastics. So it gives us a lot of convenience, and also we can find many applications from plastics. So it should be positive. But you know, sometimes we really find some concern from plastics. So we should face the concerns and solve based on our knowledge on chemistry. Yeah.
And Charlotte, when you look at the impact of plastic, what sort of things are you looking at?
Well, to start with, following on from Professor Wang's statements, it's really important to consider that plastics are applied in a really broad range of our everyday lives. So, of course, we know the very visible plastic packaging, but polymers also perform key roles in sectors like construction, where they make sure that our homes are properly insulated and that we can use a range of materials. They're very important in electronics. They're essential to lightweighting transport. Nearly 50% of a car or an aeroplane would be polymeric components. And so they bring so many benefits in terms of sustainability to our lives that we must not forget this. But there are very real concerns with what happens once we've finished using them. And we need to improve upon this so that we overcome that negative impact that they can have.
Andreas, to what extent do you think it's chemistry's job to solve this problem rather than society's problem?
I would like to extend this a little bit by saying we have an impact of plastic and we have an impact of plastic handling. This we should keep apart. And chemistry can help here, of course, by making plastics which are better suitable for the particular application they are meant for. They even enable certain applications only, this with appropriate chemistry, but it already starts in its production, that it's more sustainable, less CO2 footprint, and so on, what we all want to have, of course.
We're going to unpick that a little bit more later on. But Yoshioka, first I want to talk to you about degradability. A lot of people, when they think, because plastic pollution is such a visceral thing, people can see the plastic, they see the problem. But there's still a lot of confusion about how plastic degrades. Can you tell us a little bit about that?
Yeah, and concerning the measure about the recent environmental impact with the plastics, it is good, not good. And however, even now the lifestyle is lost without plastics. There are so many plastics produced around us to help our lives. And then if the plastic is not degradable, in that case, the plastic have a lot of impact in the environment. But plastic have a good advantage. For example, if you go shopping and buy a milk or juice with glass bottles or plastic bottles, and obviously the plastic bottles can carry more drinks in one shopping. We use less energy. And plastic degradable is important, but plastic not degradable very important for our life.
Andreas, can I ask you a little bit about, is there a way that we can break down plastic and polymers without hurting the environment?
What all we do, human beings, as we are, if we act something, we somehow, of course, have an influence on the environment. There will be never no influence. And with the degradation of polymers, of course, we also have an impact on the environment. Just to give you an example, if we degrade one of the standard degradable polymers, which are meant for degradation, we change, for example, the pH. The question is how much it is. So there will be some dosage for the nearer environment, but maybe not for the wider environment. What is most important is that during the degradation process, no toxic components are developed. Very often, of course, there is a development of, for example, carbon dioxide in the degradation of nowadays degradable polymers. So one has to make then a trade-off. Is it worthwhile to do that or not?
Yes, I actually had a question through earlier from Wei, who says, when you are sort of changing the degradability, are you making a compromise on all those attributes of plastic that makes it so useful? Xianhong, what do you say to that?
Yeah, actually, we need some trade-off between degradability and performance. But anyway, currently based on our chemistry and also our physics, we call polymer blending, something like that. Then we can make such a balance for degradability and performance.
I just want to pick up on what you said, that there is a compromise on the performance. What sort of things will be less efficient with plastic if we make it more biodegradable?
Yeah, actually, the first thing we should satisfy the function for a certain application. Then we may find a way to adjust the degradability, and we can control the length or the time, how long it will degrade. Yeah.
And Andreas, are these methods there yet? Can chemists do this at the moment?
I think we basically have the tools, but we have to put the tools together to do that better. And I would like to emphasize this trade-off situation. I'll give you an example. If we have to increase the crop production, which we have to do, we have only a limited amount of square meters on this planet Earth. We have to increase the crop productivity in the future. We might have to use the degradable plastic in order to increase this. Then we have a CO2 maybe development during this degradation, but we maybe also increase the crop production, which is of utmost importance for the future of our children and grandchildren. And this you also mean by the trade-off.
Charlotte, some people might say that if you make plastic more degradable, it's not really going to teach the world about being sustainable. They'll be like, well, if I chuck this away, it will disappear, no harm done. to what extent is that possibly going to happen?
We've discussed this at length over the last 3 days at our meeting, and we are very clear that although we can propose technical solutions that allow plastics to be broken more easily back to their small molecules, we are not proposing the indiscriminate disposal of plastics in the environment. This is not our solution to the problem. We need to use technical innovation to redesign these high-performance products, and I'm very confident that our field can do this, but the behavior of people, we need also to tackle that as a society. We are not advocating a throwaway culture and the waste of this precious material, however it is made and whatever it may degrade to. Even if those degradation products are non-toxic, we still say this is precious material. We need to recycle it and reuse it and not have it out there in the environment.
I'm glad you mentioned recycling, because that's another aspect that you've all been looking at over the last few days. Yoshioka, what problems are there with recycling plastic and polymers at the moment?
Yeah, and that reason is both technical issues and economic issues. Mm-hmm. And there are two issues is a big problem for the plastic issues. Yeah.
So it's to do with how much it costs, but also presumably the way it's done. What problems can be caused? A lot of people, Leonie's actually messaged to say that can recycling plastic be done without using a lot of energy?
Yeah, for example, and if the consumer collaborate with when through way of the plastics, and the energy used for recycling can be reduced. And then if various industrial technology can be used well, it's possible to cover the energy consumptions for recycling with energy of the manufacturing processes.
And what changes can be made to plastics to make them more recyclable, would you say?
Yeah, it's a good question. Yeah, and almost yes, it's possible to do changing with plastic plastics.
How would that change? What does that change look like?
Yeah. That question, the meaning of plastics?
Yeah,
changing?
How can you change a plastic?
Yeah, considering in our life, and maybe it's difficult, but we have to tackle plastics at good solutions, and some plastics can changing other materials. But almost plastics is difficult to change as other materials. For example, considering the electric appliances and the automobiles, they have a lot of the plastics to reduce of the energy consumption. If the automobiles changing to the old metals, in that case, the carbon dioxide emission is more a lot. For example, packaging plastics is maybe I hope to the little bit changing with the other plastics for the environmental friendly materials.
Charlotte, you want to say something?
We discussed in some detail some of the challenges with recycling, and in future it's clear that we need to have efficient separations of plastics. Technically, it's really important to realise that polymer can be recycled within a reasonable temperature range. And I say this because many times you see that people wish to replace plastics with materials that might be even more energy cost to recycle, like metals or glass. So to recycle those materials requires a very significantly greater energy input than it does for polymers. And some of the challenges for recycling of polymers involve that they are not a single thing. They are a mixture of different chemistries. And so if we can improve that separation of those chemistries, we can then develop the technology to allow for this recycling.
Xianhong, you're nodding along to everything Charlotte said there.
Yeah, as you know, there are two ways to reduce the plastic impact on the environment. One is recycle the plastic, the other one is degradation. So in some way, in some area, recycle cannot be done very well. I mean, energy and cost issue. So like in China, as you know, we have huge land for emulsion film, for agriculture emulsion film. So it's nearly impossible to recycle more than 60% or 7%. So we need biodegradation. So that means a change of plastic from traditional non-degradable plastic to biodegradable. Or in this morning, we discussed for environmental degradable plastics.
Yeah. So it's not a case of either or, it's both together.
Yeah.
Yes.
Yeah.
But so how much is it of one, improving degradability, versus improving recycling? Andreas, what do you think?
It depends on the application very clearly. Like in agricultural field, you want to have, of course, degradation more. It's next to impossible if you have a huge field in China to recollect that. Everything is simply not efficient to do that. But if you have a material, for example, like a coffee beaker we get here in a coffee shop in London, this could be nicely recycled, and there's a trash can there. And here I would like to make a point. In some countries, we have already good recycling systems. They can be always improved. But I also see other countries where not any even garbage management systems are there, not talking about recycling. And here clearly, maybe also sometimes the education is missing to have the awareness to do that. Everybody can do his own chemistry or her own chemistry by simply collecting the plastic instead of throwing that in the environment. And I think all these things have to come together. Education, garbage management system, polymers, which are, by the way, not simple materials, they are complex materials. They are like a Lego system, which have to be put together either to be clearly degradable, to be clearly recyclable, that they survive long, that they can be reused again. Many plastics could also get kind of degraded through the recycling process, and then they are maybe even useless after recycling, then only burning remains, and this can be not a solution.
Yes, tell us a little bit more about burning.
That's an interesting issue, because a plastic is also a container for energy. And we always have to make a trade-off. Is the burning of a plastic a better solution, or it's recycling? Because recycling also takes energy and is usually connected to a loss in quality. For example, if I want to use that now for a windshield for a high-speed train, maybe I would not want to use a recycled plastic. Maybe the transparency is missing because of the recycling process. Then I have to think whether this would be better to burn, at least get the energy back. This needs a so-called, difficult word now, life cycle assessment. This has to be done professionally and is done in industry. Academics usually do that less. Like chemists like me need colleagues helping here. But this has to be done more if it comes in a real application field.
A lot of people, when they hear about burning plastic, will suddenly become a bit panicked about the emissions that could come from that, and the emissions that come from recycling plastic. What plans could there be in order to mitigate the effect on climate change as you try and tackle plastic pollution as a problem? Charlotte? Sorry, Andreas.
Okay. That is an important question. We all want to and have to reduce the CO2 footprint. There's no doubt about that. We know all why that is the case. And recycling is not recycling. Recycling can be really either break it down to the starting materials and reuse it again. This is a very efficient process, but also a demanding process, which has maybe a CO2 footprint. But we can also re-engineer it and make out of a beaker maybe a table, for example, or a cloth. Then it will have a different CO2 footprint. But whatever we do, we will need some energy. Again, the trade-off is the solution. We have to see, is it easier to make a new polymer and burn the rest, get the CO2, or just to recycle it? This has to be carefully calculated and cannot be ended. Plastic is a white field. There is not a single plastic. We have a huge variety of plastics because in our everyday life, it's like oxygen. We all have to breathe here. And out in the world, we have to breathe. We don't notice the oxygen, but it's not there. We notice it. Same with the plastic.
Yoshioka, have you got anything you'd like to say more about recycling?
Now they're focusing on the carbon dioxide, but considering the plastic recycling and the plastic treatment, and we have to consider the other chemical substances. For example, the plastic containing a lot of the additives, and sometimes they added to the environment, but now that they are prohibited from using them. In addition, the process of the covering plastic of chemical raw materials can be recycled as resources, as raw materials without generating harmful substances. And of course, the carbon dioxide is one of the harmful substances. And how to treat of the plastic materials, and we have to consider and every kind of the chemical substances.
Mm-hmm. How difficult is it to make all these changes?
Yeah, and we have many types of the plastic recycling method, and physical recycling processing and chemical recycling process and the burning. And I don't like the burning naming. I want it's better to the energy recovery system.
Energy recovery.
Energy recovery.
Okay.
And the three type of the recycling is the method we have. Mm-hmm. And we have to just select which recycling system is better mm-hmm. of the each plastic materials. Depend on which is depend on the dirty one and the impurity ones, and how to the history of the how to use that one. Mm-hmm. Mm. And we have to select it to the which recycling method is better.
Okay. Something that's been mentioned a bit over the last few days is new plastics. Charlotte, what do we mean by new plastics exactly?
Well, we've alluded to the fact that plastics catches a lot of different materials, chemistries, additives, and forms of material, not just plastic packaging. And so when we talk about new plastics and polymers, we've got an opportunity here as a field and as an industry to think really carefully about the way that we design at a molecular level and at the article level the objects that we use. And so this might mean careful redesign of existing materials to make sure that they really fulfill these sustainability criteria.
What is your criteria when you come to, we want to make something more sustainable? What is the criteria that you mark it against?
Exactly as Andreas said, it's a complete examination of what happens from the very beginning of making the polymer, the raw material you use, through its use, and what happens at the end. Now, the difficulty in doing that type of assessment is how do you relatively offset different impacts? And I think we've already alluded to this. But that's what we are using already as a field and will continue to use in proposing new types of plastics. One of the really inspiring things that we've heard here at CS3 is the potential to use unconventional starting materials to make some of these plastics.
Like what?
Well, for example, we might be in future using wastes from agriculture or from other industries. We might be more efficiently using some of the plastics that are out there and reforming them into new types of chemistry and product. We might even be using CO2, that most troublesome of gases, as a raw material to make polymers from. So one of the great excitements for me here is hearing that in future we use these range of natural chemistries to improve the ability to break at the end of the life that polymer into things that can be recycled or, where the application demands it, biodegraded.
It sounds like new plastics have the potential to solve a lot of problems at the same time. But Andreas, how expensive is this, though? That's what a lot of people wonder.
Are you looking at me?
Yes. Are you not going to pay for it all? No.
Of course, the development of a new plastic is always expensive. It starts with the research, with the fundamental research which has to be done, and numbers of students and professors have to work on that. Then this has to be transferred to industry. They have to do build up the production, the quality management. It's a long process, and then finally the marketing people have to bring it in. The market has to survive the regulation and everything. But it pays off. There's no way around. I want to give you an example. We all need better batteries urgently to reduce our CO2 footprint, to collect the sunlight, save it in the battery, that we can heat our houses overnight and run the fridges also overnight. For this, we urgently need better membranes in the batteries, and these membranes are usually plastics. But the existing plastics are not good enough yet to really have the super batteries. So we are on a good way here, but there's a lot of room. It's just a single example for what we need, or a better packaging material for food packaging, that our food is longer preserved. And here is, I'm not talking about communication, transport, for example, lightweight materials, which are important for the electric cars, that they can run through London with less electricity consumption, and to other places as well. And here is the room for the new plastics. And industry, I think, is aware of that they need new plastics. They could be more aware, of course, but there's no way around that.
Are you seeing a lot of funding coming from industry into this kind of research?
That's a good question.
Question for all of you there.
If I may, I think that industry are really well engaged with this problem, and their customers and the general public are demanding this. So I think it would be simplistic to imply that only academics would be involved in solving the problem. It absolutely wouldn't be so. But what's really important is that we accelerate through the process of improving these materials. And so close working with a range of industries is going to be really important, because Andreas has given us a hint of how technologically complex, there's a really piece of customized design, even in a simple piece of, relatively apparently simple piece of plastic packaging. And so working together to make sure we get that right is really, really important, and we need to do it quickly.
What other industries need to get on board then, Xianhong?
Other industries than the chemical industry?
Yeah. For example, in China, we have such kind of new plastics like biodegradable plastics, and actually started from USA and also German, and currently in China, we have more than 1,000 factories, companies doing biodegradable plastic. So they support a lot for academic research.
As polymer scientists, we work a lot with chemical companies, with car companies, textile companies, non-woven industries, which makes the filtration, agricultural companies, you name it. It's a standard for a polymer scientist to work with all these different industry. It's important, and there's a constant communication. And you're absolutely right. Of course, in industry, it's done a lot of research, but I also think there has to be nowadays room for disruptive development, that we do not just improve the existing materials, that we also think new avenues. For example, for this battery problem, to really get a kind of disruptive development. We need not only a constant development, we have to be faster. So we need some kind of new ideas, maybe from young people which are out there and they have a brilliant idea and I come in there, and they should have the room to do that.
And how much research is being dedicated to examining the potential impacts of these new plastics on the environment? Or does that go hand in hand with developing them from the beginning?
I think the awareness is now very high. In the past, we had a discussion about the danger and less the potential of nanotechnology. And in that time, the awareness in new technology is much more. And in fact, I'm very thankful that now people talk now about plastics, because plastics somehow were given as given. It's there. It's very taken for granted. Now we talk about it. And it's so important to explain the layman out in the world, what is the plastic? What do you have in your hand? You lay in the bed and you lay on plastic maybe. You should know what I became chemist because I want to know what is around me. That was the reason. And everybody has the right to know that. And I think we have the duty to explain it in simple words, as simple as possible.
Yes, I think I can speak for the whole world when they say that they want answers, and they often want simple ones. But if they can't get simple, quick answers, then at least have it clearly explained to them that it's a bit more complicated. We've talked about all these potential developments that are being made in this field. What sort of time frames are we talking about when we're talking about making plastic more degradable, when we're talking about improving recycling? Is it going to happen in the next 10 years? To what extent is it already happening?
There's the geographical aspect there. I think in China they are much faster.
Yeah. Well, let's go around the world with the answer.
It really happens. As you know, currently new plastic like biodegradable plastic is still in the baby stage. So we need more chemistry and physics and interdisciplinary cooperation to push such new plastics for real application. Yeah. So, for example, like in China, our government encourages postage bag and garbage bag, and also in agriculture emulsion film. So, encourage whether we can find a way to make such new plastics. This has less environmental impact and also less public concern on the final after use, you know. So
I would say, how aware do you think the general public are that these changes are already being made and they're seeing them on their high streets or where they live?
You went over a number of years?
I want you to place a bet right now.
In former times, the development of a new plastic took about 20 to 30 years. There's of course no more there. We have now much better infrastructure to do the development. It takes some time. If you take a pill against headache, it also takes some time until the headache goes. Yes. But it is not like that. Of course, here I think a realistic aspect could be with the nowadays ways of communication and what all we know already 10 years. I just now say you can oppose that, but I think 10 years from scratch to that we see it on the shelf.
Okay. 10 years. Brilliant. We'll all meet.
Don't take me on that.
Yoshioka.
In the case of Japan,
yes.
And the Japanese government make a plastic strategy until the 2030. That the main target is the recycle ratio will be doubled until now. And then the biodegradable and bioplastics, the market is more expanded to the totally the 2 million ton production in Japan. Wow. But I think that amount is too low. Maybe it's very, very
too
high.
Low. You need to put higher.
Yeah. But Japanese make that strategy. And then because if we use the new plastics, including the bioplastics, in that case, to lowering the cost, and in that case, we need to do the more expanded market. And then that strategy is the recycling is double and new plastics making until the 2030.
2030. Okay. I'm just going to take a step away now because we're getting a lot of questions coming in from people around the world. Elizabeth, what questions are coming in?
So we've got people tuning in from all around the world, from India to Bulgaria. So one question we've had from Teresa Mnoguera is, are there any studies to create plastics from agricultural waste? And if so, can you give any examples?
From agricultural waste?
Yeah.
Xianhong, will you be the best to speak about that?
So it's a very important question, you know. Currently in China, we used nearly 2 million tons of polyethylene for emulsion film. So they cause a lot of agricultural waste and also may be harmful for soil safety. So in that case, at first we encourage recycle of such plastics, but still we find in huge land we cannot recycle so easily. So we may need biodegradable plastics to push in to reduce the agricultural waste. Yeah.
Andreas.
Maybe I can extend the view a little bit on this interesting question, because Charlotte and myself and many other colleagues work now on using the orange shells ingredients, which are we get a lot of orange juice and we get orange shells, and how to use the orange shell, which is also agricultural waste. And there's a compound in which we all know. When you look on the back of your shampoo bottles, you might read limonene. This comes out of the orange shells, but our groups do, for example, with CO2 out of this a very nice polymer. So one can use such ingredients of real agricultural waste from a plant to make plastics. I think it's very nice to do that. It's not yet in application, as far as I know, but many companies are interested in that because also available in large amounts, not a smaller compound, which we can get out. And what else to do with the orange shell? Some countries use the orange shells, like in Brazil, they use it a lot nowadays for making food for cows and so on. But in other countries, like in China, orange shells, as far as I know, are not used so much. They're huge amounts, but not used for that. So there's a large potential.
But in China's case, and China's try to make a lot of the biodegradable plastics in the agriculture. But in that case, it's ugly. But there are many kinds of the agricultural plastics, such as house at the cupboard. In that case, it's difficult to do the biodegradable plastic. In that case, we need to recycle and collect it. And we have to consider how to the degradable, how to the collect of the waste plastics. And the two types of the treatment is necessary for the sustainable plastic use.
Charlotte, do you want to add anything to that point?
So there are a number of plastics that are currently sourced from plants, but at the moment, the majority of those materials are still quite small scale. The largest scale example would be polylactic acid, and that comes from lactic acid that was originally sourced from glucose. And at the moment, that glucose source comes from crops that you might eat. But actually in the future, there's very intense research and real possibility to substitute that with either non-edible crops or co-products of agriculture. I guess we have to always be a little bit careful with the term waste, because what might be assumed to be a waste from one industry can find over many years of human evolution other uses, right? But I would say co-products, going along with other industries and finding uses for things that are currently not so valuable to them. That's an interesting idea for making plastics, and one that certainly the community is really engaged in researching.
Yeah, it sounds very promising results thus far, and there's a lot more room to go.
Absolutely.
Another question from the panel.
So Sam Hill on YouTube wants to know, is there still a risk that biodegradable polymers will still break down into microplastics that could cause further environmental problems?
I think it's a very good question, and one in which the kind of environmental and toxicological community are very actively engaged. And at this point, I think it would be premature for anybody to say no in answer to that. But I think that the early signs in testing of those materials is that the design is appropriate. There may be things to improve about the relative amount of time that it takes for things to biodegrade. We need to be very careful because the environment is a complicated place. But we are engaged in the scientific discussions, and we've seen that in a very inspiring way at this meeting. We've seen, both very compelling evidence of the problem of pervasive microplastics that were made in the old-fashioned ways, and the research that's going to make sure that we avoid these unintended consequences in future.
Yeah. Xianhong, do you see a world where we won't be talking about microplastics so much in the way that we currently do?
Yeah, during the past 2 years, we heard a lot of microplastics. Yeah. Actually, for such kind of microplastics, we can find it in the sea or also in the land. So it's true. But we can find a new way. If we can use new plastics, or if we can use like biodegradable plastics, it can be degraded into not a microplastic, 2 molecules, yeah, and like CO2 and water, something like that. So it should be, we needn't concern about microplastics from such kind of new plastics. Yeah.
It's all about breaking things down into nicer things rather than microplastics. Andreas?
We have initiated a large research program on microplastic involving more than 30 research groups in Bayreuth and surrounding universities, because we don't know anything about the effect of microplastic. We know it there, more or less. Know anything, what does it do to any organisms and to ourselves also. We're interested. We don't know how it is transported through the different environments, water, air, and soil. It is happening, but we don't know how, and we don't know how it's being formed, because microplastic is not microplastic. It can consist out of many polymers, many ingredients which are in there, and what is really a danger, if there is any danger. We don't know it yet, and we have to find it out, and there are worldwide very intensive research efforts now to find out what does a microplastic do to us. And then only we can find solution to do something against it. And I would like to emphasize it's not a way to fish it out of the water in the ocean. You destroy so much organisms doing that, many of us strongly oppose that. Better is to avoid it at all, this is a better solution, or find other solutions. But for this, we need to know these mechanisms. And scientists and industry as well is now active in battling this problem.
Would you agree that progression with things like degradability and recyclability can't really happen unless we know more about microplastics?
No, I would not agree on that, because these are two different issues. For example, the microplastic is the majority is being formed by polyethylene, polypropylene, polyethylene terephthalate, just to name some of them, which are so-called commodity plastics, which are used in large amounts. In contrast, the degradable polymers, which are now in the market, are used in by far lower values. You might find them nowadays on a compost plant because they don't degrade in the time as they should degrade, as the compost is bringing out of the fields. But this is really a relatively small amount in comparison to the so-called big plastics.
I think it's really important to talk about the timescales for technological deployment in this field. So there's an immediate term crisis, and we need immediate term research to understand what's happening in our environment. But we also need to kickstart research rapidly so that we can solve some of those problems. And we simply cannot afford to wait until we have all the answers about polythene before we begin bringing through the research, through that pipeline that takes time, so that we have materials that don't give rise to these problems. So we have to talk to one another, we have to keep the two communities really in active discussion, but we can't do this in a linear way where we wait for the answer there before we make change.
It's got to be everything happening at the same time.
Absolutely.
Elizabeth, I think we've got time for one more question before we have to wrap.
Georgina Gregory on YouTube wants to know, what do we do about the plastic already in the ocean?
Andreas, you touched on this just now, didn't you? What do you do about the plastic already in the ocean? You're not a fan of removing it with a net.
If I would know the answer, I would be maybe not sitting here. As I said already, I think the fishing out of that is not a solution. Like having big nets which go around and fishing out the plastic may cause more harm than let it being there.
What is the solution then?
In fact, I have no proper answer for that to do with the plastic which is right now in the ocean. The question should
Does anyone have just
how much we have already.
I'm sure if we all knew the concrete answer, it would be happening already.
And finally, I want to say it, and everyone should be aware that not just a bad aspect of the plastics, but also they play important roles such as improve quality of life, such as reducing energy consumptions. And I believe that the current plastics issue, current plastics problem, such as microplastics also, is one of the challenging that struck our lifestyle changes. And this issue is not focusing the plastic, and that is issues to send to the how to the lifestyle changes.
That's an interesting point, Yoshioka, because a lot of people want to know, well, what if I take one thing away from this? What should I be doing so I can help with this plastic pollution problem from your points of view?
Everybody should stop immediately dumping garbage into the ocean, which is still happening. And if we would stop that immediately, this would help a lot. If everybody in the UN or wherever would commit themselves, we don't dump from boats and I don't know what, any garbage in the ocean anymore, this would help a lot.
Xianhong, you're nodding along.
Yes, currently it's so difficult to deal with the plastic pollution in the ocean. It's very difficult. Maybe we can collect, but it takes a lot of, I think, energy and cost. Yeah, is cost issue. So I agree with Greiner. Yeah. So currently we just need more education and so to stop pouring plastic into rivers and ocean.
And Charlotte, would you like to say anything?
So I do think that it's a very interesting question that we're asked. And we heard at the conference of the importance of models and understanding of what happens to that plastic that's in the ocean. And I think that that's essential, that we build a almost world-scale model of what's going on, and by we, I mean the community of scientists engaged in this activity, so that we understand if there are easier opportunities to remove some of it. So unlike Andreas, I think if we can take some of that plastic out, we should explore every possibility to do so until we are sure that there's not a negative impact, because at the moment it is not clear what the impact of those materials in the sea is. And some of the interesting research here that we heard about was how often small particles get beached and washed away from beaches and so on. So that was certainly very eye-opening for me. And of course, you know, a natural consequence of tides, one might say, but are there opportunities through really understanding that to grab some of that plastic out and you know, at least try and limit some of this effects. Of course, the comments that my colleagues make about immediately turning off the tap in terms of appropriate waste management is highly important.
Thank you all so much for sparing the time. I know it's been a long 3 days, and I'm really glad that you can share with everyone what you've been talking about. And the full results will come out next year sometime, I believe. But until then, thank you for giving us this insight into your world. It sounds very, very optimistic, but all the role that chemistry can play. But you're not alone in fighting this problem. It seems like a lot more work is needed around the world and across the board in order to tackle this plastic pollution problem. I think that's all we've got time for, I'm hearing in my ear. So thank you very much for joining us today. The discussion here, the broadcast may be over, but the argument and the discussion will continue online, so please keep leaving your comments. Those hashtags again are progressive plastics and RSC sustainability. We will be milling about and we will be answering some of your questions online after the session. Until then, thank you very much for tuning in.